A tornado is defined as a rapidly rotating column of air attached to a thunderstorm and in contact with the ground. When these rotations are not yet in contact with the ground, we call them a funnel cloud. And it's an important distinction to make because when you have a funnel cloud passing over, it means that the very destructive winds of the tornado have yet to extend all the way to the surface. Now, when they do, they can be very, very weak, sometimes having wind speeds less than 50 miles an hour, or they can be exceptionally strong and violent with wind speeds over 200 miles an hour. In fact, let's categorize them just that way, from weak to violent. Now, I know later on in these lectures we're going to be talking about the Fujita scale and the enhanced Fujita scale, but right now let's just talk about these three different categories. We see time, wind speed, percent of deaths, percent of tornadoes, and width. Starting off with time, generally your weak tornadoes aren't touching the ground for too long, maybe just a few minutes. The stronger they get, though, the longer they tend to survive. The stronger they get, the faster the wind speeds become. Your weak tornadoes may have wind speeds less than 120 miles an hour, but between 120 and 200, we're talking about these very, very strong, and faster than that, we're talking about your violent tornadoes. I break them down into these categories so that you can see these two columns. These are the two most important columns on this slide. What this tells you is that 85% of all tornadoes are weak, and they are responsible for only 5% of all fatalities. Combining your strong and violent, which add up to a grand total of 15%, they are responsible for 95% of all fatalities. This means that the weak tornadoes are the most common and do the least amount of damage and kill the fewest number of people. But by chance, if you come in contact with one of these violent tornadoes, they are responsible for so many of the deaths in the United States. Now, one last thing before we move down to the average tornado information here is I want you to think about the width. We can see that as we go from weak to violent, the tornado seems to be getting wider. Now, that's kind of counterintuitive because we know rotating systems, as they expand, should slow down. And we're going to talk about why that is in another lecture. But right now, just keep this in mind. Your weakest tornadoes tend to have widths of maybe 100 feet or so. Your strong ones, man, they can get over a quarter mile. Your violent ones, maybe even over a mile. So this is an important feature to be thinking about later when we're talking about tornado size and what controls it. So let's talk about that average tornado. The typical size, well, it can range anywhere from 150 feet to a mile plus, and that's the diameter we're talking about. Normal is about 250 yards wide, so when we average them all, it's about 250 yards is the typical width. How long do they spend in contact with the ground? On average, it's about 10 minutes, which means given their forward speed, they basically make a track length of about 4 miles. What's the average wind speed of a tornado? Well, the average wind speed of a tornado is 110 miles an hour. That gives it an EF scale ranking of EF1, and generally we find that these tornadoes move from the southwest to the northeast, following the supercells that produce them, and they do so at a speed between 20 and 40 miles an hour. Now, the fastest tornadoes that I've ever seen or ever heard of may move at speeds approaching 70 miles an hour, but those are exceptionally rare. Now, when it comes to the average warning time for tornadoes, currently that average warning time is 13 minutes. But that's a warning time over the last 20 years. What I want you to understand is that our recent tornado outbreaks, because of the enhancements of our Doppler radar technology and a great storm spotter network, we've been averaging about 30 minutes with our recent outbreaks. And it is exceptionally rare for a tornado to not go warned. Finally, I want you to remember this. When it comes to how tornadoes kill people, it's from debris. That's stuff flying in the tornado. Tornadoes kill you by blunt force trauma. Floods drown you. Heat waves can get you with aggravated illnesses. But tornadoes, they kill you directly with blunt force trauma, throwing debris at you. And to kind of make sure that is remembered, I want to show you this video. We're going to go to this town in Nebraska called Pilger. I'll start the video right about here. What I want you to look at in this video is all of the deadly debris flowing around this tornado. So check it out. And you can just see all of the stuff that this tornado has picked up, and it's about to pick up a whole lot more. It's right now going through part of this very small town, but as it does so, watch.
Oh, it just hit something. Oh, it's flying debris, look. Oh, wow.
That's someone's roof. Look at it just getting torn up and thrown around this tornado. And as it passes through the main part of town, look at all of the debris collecting over here. That debris is moving at nearly 200 miles an hour. And these people making the video are completely helpless at this point. They have to wait till it's gone through and then go through and see if anybody needs help. But look at all that debris. That is the deadliest part of any tornado. Now, what was amazing about the supercell that produced the Pilgrim, Nebraska tornado was that it actually produced two. Those are two separate tornadoes from a system of supercells. Incredible to see something like that. And I thank these tornado hunter guys for giving us this picture. Incredible to see this. All right, when we talk about tornado fatalities, we've got some statistics to look at here. From 1940 to 2013, the time period we're going to look over, we can see that we've had some major outbreaks. What's interesting, though, is that after about 1975, we really only had one major outbreak that was responsible for killing a lot of people. Even though we still had just as many tornadoes and even more people that were vulnerable, since the 1970s, we had several things that came online in the meteorological community that changed the game with how we forecast and detect severe weather. Primarily the launch of geostationary satellites, also the invention of Doppler radar here in the 1980s. Vastly improving research combined with better technology meant we are having fewer fatalities, but that does not mean we can't have huge events that still claim a lot of lives. Well, the statistics are these. The 30-year average is 70 deaths per year. The 10-year average is 105 deaths per year. And since 1940, we've recorded around 2,500 fatalities from tornadoes. We'll talk about these two outbreaks here in a few moments. The April 3rd and 4th, 1974 super outbreak, which held the record for the most tornadoes in a single 24-hour period, until this event, the April 27th and 28th, 2011 outbreak, which was absolutely incredible. Now check this out. On the left, let's start over here. These are weather fatalities through 2016. The yellow column is the 30-year average. The one in the middle here is the 10-year average, and the red is the fatalities for 2016. The tornado column is right here. 2016 was really a down year in terms of tornado fatalities with 18. But one of the reasons why this is the deadliest form of weather in the last 10 years is because, here's that column right here, 105, is because of this outbreak in 2011, which killed 553 people. See how it dwarfs everything else? Well, that year when I was teaching about tornadoes, that was our feature story from that year. Incredible outbreak of severe weather. We'll see it in a few moments. When it comes to the cost of cleaning up after what we call convective events, so this includes all types of thunderstorms, we can see that with time, the cost is increasing. You see, this has been normalized to $2013, and what we can see is that our insured losses are growing when it comes to severe thunderstorms. And there's that 2011 year with the huge losses from all those tornadoes in April. Again, we'll take a closer look in a few moments. Now, tornado fatalities, I want you to key in on one statistic, and that statistic is shown in the top left corner. You see, what you've got there in the top left corner is tornado fatalities by location. And what it shows you is 44% of all tornado fatalities are mobile homes. If you live in a mobile home or find yourself in a mobile home, please listen carefully. Abandon it if a tornado is coming. In fact, my recommendation to you is if you step out the front door and see a tornado coming toward you and you live in a mobile home, run at right angles from it. Don't stay in the mobile home. Mobile homes can be rolled over by very weak winds, and as they do, all of the stuff that is in them, it rolls with it and basically crushes people to death. Plus, when it's not on a platform, the mobile home will crush itself, causing fatalities. Look at the second most common location, permanent homes, and the third, vehicles. Why these three locations? Why not churches or long-span stores like a Lowe's or Home Depot or a Walmart? Why not schools? Well, when you look at this, what you need to understand is the most common time for tornadoes is the late afternoon and early evening, when people are either at home or driving home. That's why the statistics look like this. Now, when it comes to the states which have the highest tornado fatality rates, I want you to see what the top 5 are. Beginning with number 1, it's Mississippi. Mississippi has tornadoes all year round, and we'll talk more about Mississippi in just a few moments. Number 2, Arkansas. Number 3, Alabama. Number 4 is the state of Illinois. Number 5 is Indiana. Again, that's Mississippi, Arkansas, Alabama, Illinois, Indiana. Those are your top 5 states in terms of tornado fatality rate. Now, you might be surprised. Why not Kansas, Oklahoma, Texas? I mean, shoot, the Wizard of Oz, the movie was shot in Kansas. Shouldn't we have our highest tornado fatality rates there? Well, not really. First, Indiana, Illinois, high population states in Tornado Alley. Mississippi, Arkansas, Alabama, tornadoes all year round. We'll talk more about that in just a few seconds. So you see there's several things that kind of contribute to that tornado fatality rate. Now, what you've been watching in the upper right-hand corner here is showing you where tornadoes occur throughout the year. January and February, see how they're mostly concentrated down here in the south. As we go to March, April, May, the most busy month, and then June and July, we see the tornado threat spreading toward the central United States. But what you see here is that all year long, even in winter, we can have tornadoes along the southern states. That's one of the contributing factors as to why Mississippi, Arkansas, and Alabama are your top 3. So very important point to think about there. I also want to show you this. One of the big reasons why Mississippi ranks as number 1 is because of this map, which shows you the continental poverty divide. You see, it shows you poverty color-coded by county. And here we have very low poverty, and here we have very high poverty. Mississippi is a very impoverished state, and what you end up having in Mississippi is this situation. You have a lot of immobile people, both socioeconomically and maybe even physically, that live in mobile homes, the location where we have the highest fatality rate. Combine that with a lot of very heavily forested areas down in Mississippi, which means you can't see the tornado coming, and also with the fact that they get a lot of nocturnal and winter tornadoes, and you have a recipe for disaster. Plus, there was an interesting publication that came out a few years ago that surveyed people in the South to try to understand why and how they responded to tornado warnings. They said that one of the biggest contributing factors to tornado fatalities in the southern states had to do with Southerners' tendency toward fatalism and a lack of organized government. And the National Weather Service a lack of trust in organized government. And basically the fact that the National Weather Service is an organized government entity issuing tornado warnings, well, they've discovered that a lot of times they're not listened to. Now, why not the highest rate over here again in Oklahoma, Kansas, and parts of Texas? Well, even though they have a lot of tornadoes here, people here are used to them. They know what time of year they come, and it's wide, vast, open prairie. You can see tornadoes for miles and miles and miles. They're easily warned. That is not the case in the southern states down here in these states. So I just wanted to bring all of that kind of to your attention as we think about where people are killed by tornadoes. Now, the state of Illinois actually played host to the most deadly tornado in U.S. history. Had the National Weather Service existed in 1925, they may have drawn this tornado watch box before this particular tornado formed. Remember, tornado watches mean that inside of a particular area, all the ingredients are coming together. Well, on this particular day in 1925, we have what was called the Tri-State or the Great Tornado of March 18, 1925. To date, it is the longest single-track tornado that we have on record, although there's some argument over if it was a family of tornadoes or if it was a single-track tornado. But it ended up killing nearly 700 people, many of them in southern Illinois. It gets its name Tri-State from going from Missouri to Illinois to Indiana. This is what it did to a 3-story brick school. So you can see that this particular tornado was very powerful. But one of my most favorite of all-time tornado pictures is this one. It's where a 1x4 was thrown through a 2x6. Incredible to see the destructive power of tornadic winds. Again, Illinois playing host to the most deadly tornado in U.S. history. Now, recently, we've had some very, very deadly ones as well. For example, in Joplin, Missouri in 2011, we had an EF5 tornado that killed 162 people. It was the deadliest tornado we had on record going back 60 years. What you're looking at here is a before picture. This is before the tornado went through, and this is after. Incredible to see the destructive power of an EF5 tornado. They are the most violent, and you can clearly see what they do to homes and what it did to this school. Incredibly tragic event. Okay, I got a couple of fun questions for you mid-lecture here. How many tornadoes hit the United States each year? It was in one of our previous lectures. Do you remember the number? Well, it turns out that number is about 1,200. But here's another interesting question. What percent of the world's tornadoes are found in the United States? Is it 10%, 25%, 50%, 75%, or 90%? Well, I'm going to give you the answer to that one in just a few moments. To understand where tornadoes are in the United States, let's look at a map like this. 1950 to 2011, each one of these red lines shows us where tornadoes have occurred. You see, this whole area in here is basically where we have the most kind of frequent tornadic activity. But we're going to break this down into a couple of different areas in a few moments, a couple of different tornado alleys. Tornado touchdowns by latitude and longitude, this is really kind of neat. You can see that we kind of have two peaks here in the distribution in terms of latitude, one right in through here and a second right in through here. Pretty amazing to see how that works. Also, when it comes to longitude, the peak runs right up the middle part of the country through Texas, Oklahoma, Kansas, Nebraska, right in through there. So neat to see tornado touchdowns by latitude and longitude. When it comes to Canada, they have them too. But like most things in Canada, they're concentrated along the U.S. border. They have about 100 tornadoes in Canada each year, which is about 5% of the world's tornadoes. I also want to show you Europe. On average, there are about 300 tornadoes in Europe each year. And so you can clearly see here where they're distributed. Neat to see that other places on Earth get tornadoes as frequently as we do. All right, when it comes down here to central Illinois, I want to show you county by county what tornadoes looked like as they were reported from 1950 to 2013. You see the three most common counties were Champaign County, McLean County, and Sangamon County. And you might be asking yourself, why? Why does it look like that? Why do these counties have so few and these counties have so many? Well, this all has to do with population. Here you have Champaign-Urbana, Bloomington Normal, and Springfield, three of the largest cities that are in central Illinois. Well, what about Peoria? You gotta remember, Peoria's population is spread out across all three of these counties, so that's why it looks like there's fewer. Plus, a river runs right down the middle of Peoria, which may have an impact on this as well. But that's the reason why these have more reported tornadoes than other counties. There's more people to see them there. But Champaign County, where the University of Illinois is, 71 reported tornadoes from 1950 to 2013. All right, a moment ago we were talking about where tornadoes are geographically in the United States. I want to introduce you to our two alleys. First one is called Tornado Alley. The second one's called Dixie Alley. Now I've highlighted Tornado Alley for you right here. It's a huge area. Texas to North Dakota, Nebraska all the way to Ohio. It's a large section of the country where we have very, very frequent tornadoes. Dixie Alley, though, is another spot right down here, which we're going to talk about in a few moments. Now, why do we have these alleys and what's going on here? Well, tornado alleys are formed where we have these four ingredients: the unstable atmosphere, the strong wind shear, the surface trigger mechanisms, and lots of moisture. Where they come together most frequently, we have our tornado alleys. Now, I'm going to show you what the 2011 reports look like. You can see during that year a whole lot of severe weather reports coming from tornadoes down here. In fact, April 2011 currently holds the records for the most tornadoes ever in 1 month at 747. Most of them happening in what we call Dixie Alley, which is this branch of the tornado alley right down here. Now, this particular area, again, can get tornadoes year-round, but we can clearly see how bad that April 2011 was at 747 tornadoes. You know, something kind of interesting to talk about here. A few years ago, in 2008, I had an exchange student who came over from France, and his name was Yanni. And Yanni was fascinated by our tornadoes. Well, when he went back to school back in France, he sent me an email in late August of 2008. And it was all about this tornado that went through parts of France. One tornado. He said it's been in our news for 3 straight months. He goes, and it damaged a barn. My response back to him was that 2008 in the United States was one of our most active tornado years on record. And by the time France had recorded its one tornado, which did a little bit of damage to a barn, we were already approaching 2,000 reports of tornadoes in the United States. And that brings me to an interesting statistic. Right down here, well, here's the answer to the iClicker question. 75% of the world's tornadoes occur in the United States. In 2017, this is late mid-October when I'm making this video, we have already had 1,441 tornadoes, making this so far the third most active year on record over the last decade. So it's important to see how active 2017 is compared to average, which is kind of this dashed line that runs right through the middle of our graph. But again, this just shows us where we have tornadoes most commonly in the United States. And again, the U.S. is the most common place in the world to have them. All right, that April 25th through 28th outbreak was incredible. You can see all of the separate tornado watches and warnings in this graphic in the upper left. And over here on the 27th, all of the different tornado warnings, all the different tornado reports, which is one of these red dots. Incredible. We had 292 reports in a single day, smashing the record set back in 1974. The SPC was way ahead of this. They had a big area of high risk set out on that day. They knew this was coming. But when it was all said and done, sometimes you just can't avoid disaster. 355 tornadoes over the 3-day time period, 348 confirmed dead, 11 billion plus in damages, and what was very rare, 4 EF5. That's the highest ranking. 4 EF5 ranked tornadoes. Absolutely incredible. That event eclipsed this one. 1974, April 3rd and 4th. We had set a record back then of 148 tornadoes in 24 hours. Notice this about both of our huge tornado outbreaks. They did not happen in Kansas or Oklahoma or Texas. They were all in the eastern part of the United States. They were all maybe in the southern part of the U.S. too, down here in parts of Mississippi, Alabama, Georgia. Keep that in mind. That's important. We don't just have tornadoes in Oklahoma. Finally, just to let you know, when you look at all the statistics, turns out because of this that April 3rd and April 27th have the highest statistical probability of having a tornado on that day that produces a fatality in the United States. So the next time those dates roll around, April 3rd or April 27th, be on the lookout, okay? All right. What I want to finish up this video looking at here is the number of tornadoes per state during the month of November. So from 1991 to 2010, they found the averages. And for the state of Illinois, it's on average going to experience 1 tornado in the month of November, which makes this next event incredibly rare. The Storm Prediction Center had issued not only a high risk, but they'd also issued a PDS watch. PDS stands for Particularly Dangerous Situation, and it is up to the discretion of the Storm Prediction Center employee who is issuing the watch to call it a PDS watch on any given day. It means that not only are the conditions coming together, but they are coming together nearly perfectly to produce an incredible outbreak of severe weather, and it was centered right over parts of Illinois and Indiana. This was a day I will never forget. Now, the Storm Prediction Center saw this event coming 5 days in advance and nailed it. They did a perfect job of predicting where this was going to be. So we had a lot of lead time in this particular forecast. Here are the ingredients. On that day, this was a sounding launched in Lincoln, Illinois. We had a ton of CAPE, over 2,000 joules per kilogram. See all the positive area between the dash line, which is the parcel line, and this line here, which is the temperature line? In addition to that, we had an enormous amount of wind shear. Our dew point temperature was 63 degrees Fahrenheit. That's well above my 60-degree threshold. And we had a front that was racing through. Let me show you everything coming together. Earlier, before the storms even got going, we saw when we plotted out the CAPE values, a huge region that was over 1,000 joules per kilogram of CAPE, kind of a ribbon of instability coming up out of the Gulf of Mexico going clear to Chicago. The atmosphere was unstable. We had plenty of surface moisture. That white line I just drew there showed you exactly where the 60-degree dew point temperature line was located. Lots and lots of high humidity air coming right into Illinois and Indiana. Was there a front? Of course there was. A big front moving through the state. That's going to be our trigger mechanism. And what about our wind shear? Well, our wind shear, we had a 20-knot wind at the surface, and just above the surface, about a mile, we had a 50-knot wind. That is an enormous amount of wind shear. And that actually got the wind spinning like a tube in the atmosphere. We call that that kind of rotation in the low levels of the atmosphere helicity. Kind of shares the name with like the double helix, which is what a DNA strand is kind of modeled like. And we had helicity values on this day that were way up above 200. I'll be honest, I get pretty excited when I'm storm chasing if I see helicity values over 100. We had some locations in parts of Illinois and Indiana that were approaching 300 on this unit scale here. So we had all of our ingredients. And when it came together, it produced this tornado in Washington, Illinois. Check out the video. Quick disclaimer, the video may seem a bit graphic. There's also some rough language in it, but I want you to see the power of this tornado. Pay attention to the debris.
Holy shit. Holy moly. All right. Holy shit. All right, I gotta go. I'm coming, honey. Shit, where you at, hon? God damn, it's bad. All right, stay down, honey. Oh, shit, Josie. Uh-oh. We're gonna get some shit here, honey.
Is this gonna save us?
I hope so, honey. Oh my God! Holy shit! Oh man! Shit!
Don't go out there.
No, not yet.
No.
Oh.
Save us.
Oh my God, Josie.
What?
Holy moly. Oh my God. Our house is freaking destroyed, Josie.
Wow, look at that. Now I want you to watch that video to see a few things. One, look how fast the tornado approached and went over. Incredible how quickly the event starts and finishes. Notice that it destroyed the exterior walls of this particular house. That's because this house was actually right on the edge of the tornado. One of my former students, Grant Johnson, sent me this picture. His house was also on the edge of the tornado. Now where his house was, compared to that man's house, was right in through here. And the main track of the tornado was just a little bit further to the left of his house. Incredible to see this destructive path through Washington, Illinois. From above, you can see the scar cut through this community. Incredible to see that. 190-mile-an-hour winds, strong enough to give it the EF4 ranking on the Enhanced Vegeta scale. One of my students, Nick Barth, took this while flying. Again, you can see the scar cut across that neighborhood into the surrounding fields. Incredible to see that damage and destruction. Alyssa Ift gave me this incredible picture showing you the swirl marks in the field as the tornado's suction vortices went through. Pretty amazing to see that as well. One of my former students, Mackenzie, sent me this picture just showing you the aftermath. You know, this took a long time to clean up. But I want to tell you something very important. When we talked earlier about how Mississippi has the highest fatality rate, I want you to compare it to this particular scene. You see, this is Washington, Illinois, a more affluent neighborhood inside of a more affluent small community outside of Peoria. You know, in Mississippi, where we don't quite have this affluence everywhere like we do in pockets in Illinois, Damage and destruction like this would have been complete and would have taken a long time to clean up. But in Washington, Illinois, the outpouring from the community, plus the fact that almost everybody in the area that was destroyed was fully insured, meant that this area was cleaned up. In fact, we tried to send a group of students from our department to go there and help with the cleanup efforts, and we were actually turned back. They had too many people volunteering. Keep that in mind when you think about how big of a disparity there is when it comes to cleaning up after severe weather damage across the country. These storms produce massive hail. You can see here one hailstone about the size of a baseball, maybe even bordering the size of a softball. And I want you to see this. See, here's a radar image of that same supercell after it had went through parts of Washington and was moving toward the north and east, still warned. You see, this feature right here on the backside is called a hook echo, and it just passed over Interstate 39, which is right here. And before it passed over, there was this couple that was driving in this vehicle, and they're going to drive through the hook echo, and I want you to see that. Check it out. So that's
we are just witnessing my first tornado.
Right, that's the tornado.
We're just north or south of Minoka. This thing was 4 separate ones, and now it's turned into one big one. Jim's trying to get us the hell out of the way as fast as he can. Oh my God, this thing is huge. And it's coming fast. Okay, this is as close as I ever want to get. Go, 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 go. Oh my God, it's huge. It's huge, it's huge, it's huge. Oh my word. Look at all the crap that's in it. We are going right past it. We need to get past it. We're just going underneath it, actually. Oh my God. You can feel the temperature change.
Okay, what they just drove through.
Some hail, some debris.
What they just drove through was the hook echo. Before that, now I gotta translate this because this image is not at the exact time, but move this storm back this direction. As they drove south, they were out ahead of it, and then they just drove through this hook echo. On the inside of that is where that tornado was located. And Chris, who took this image, was right here watching this tornado. So that's not these people here, but this was one of my former students over here watching this. Incredible, incredible to see this. Now again, what Washington looked like after 190 mile an hour winds was this. Incredible to see this damage and destruction from a powerful, powerful tornado. In Champaign, we didn't get that tornado, but we did get some strong, what we call synoptic scale winds. And one of my former students, Rachel, sent me this picture. So while all that damage and destruction was happening in Washington, Illinois, we still had some pretty interesting winds here. And this shed blew across the Target and Lowe's parking lot, landing right on her car. Not tornado damage, but still some strong winds way outside these storms as well. So now we've got this kind of overview. We understand where tornadoes are in the world. We know where they are in the United States. And we got a chance to review what those ingredients look like as they come together to make a powerful tornado. So with that, I'm going to go ahead and wrap up this video. Thank you for watching.